Thank you, Amy. So these are my collaborators: Julio de Leon in Spain, Marco Delbo in France, Javier Lecando in Spain, Sandra Morbidelli in France, Noemi Pinilla at the University of Tennessee, Ben Lorenzi in at the TNG, which is an Italian telescope in the Canaries, and then Victor Lilagoa, which is a graduate student in Spain. I am from the University of Central Florida in Orlando, and we just got funding from Serbia, and our institute is called Center for Lunar and Asteroid Surface Science. So here's the outline. I'm going to be telling you a little bit about the discovery of water ice and organics on 2 asteroids, but we believe that it's present on many more. It's just these are the only 2 that have high enough signal noise to unequivocally identify those 2 components. And then I'll be telling you a little bit about these main belt comets in the Themis family and elsewhere in the main asteroid belt. And their activity has so far been explained by the presence of water ice on their surfaces. And then I'll tell you about 2 of these activated asteroids that are in the near-Earth space, 4015 Wilson-Harrington, and then 3200 Phaethon, and briefly touch on the relevance to space missions, and then the conclusions. Since such a short talk, and I may or may not get to the end, let me give you the conclusions now. So water ice and organic molecules on 24 Themis, 65 Cybele, possibly on many other main belt asteroids. And at the ACM meeting, there was some results that indicate that Trojan asteroids also have water ice and organics. 2 main belt comets in the Themis family, we looked at them spectroscopically, and we found out that they looked spectroscopically like other Themis family members and not like captured Jupiter family comets, so I'll touch on that. Water vapor has been now detected around 1 Ceres, and since these main belt comets are basically objects that have a coma and or a tail and are in asteroidal orbits, let me be a little bit provocative and say, should Ceres now be called a main belt comet since water vapor has been detected around it? So then I'll tell you about these two objects and why I believe that they deliver meteorites to the Earth that have not been recovered, but they do, and then the relevance to the space missions, and specifically I'll give you the examples of the relevance to Bennu, the target of OSIRIS-REx, and the relevance to JU-3, which is a target of the JAXA Hayabusa 2 mission. Okay, so in 2010 we published these 3 papers. The first 2 in Nature, reporting the detection of water ice and organics on 24 Themis, and then a few months later on 65 Cybele, and we found that the spectra of these 2 objects were very similar. The signal noise on Themis is better than on Cybele, but you can see that the spectra is quite similar. And from this area, we identified water ice. Here are the models from the Rivkin and Emery paper, showing the very nice fit to the water ice in this region. But you can see that at longer wavelengths, the ice model is always above the spectra of both objects. And we actually went and did the spectral modeling of this part of the spectrum, and this is the water ice model alone, and then we added some organics, which is actually 5% of ice stolen, the optical constants for which were actually done here at NASA Ames in a paper by Kari et al. And so the organics are identified from their CH2 and CH3 stretches. We don't know what the composition of the organics in these asteroids is, but it's probably a combination of both aromatic and aliphatics. It turns out that since our papers came out, there's been considerable work done in this area, specifically in the paper by Takir and Emery. And here are Themis and Cybele, and there's a whole group of other asteroids, mainly in the outer belt, that have absorption features similar in shape to those of 24 and 65. It's just that the signal noise in them is not sufficient to unequivocally identify water ice, but there's possibly water ice here. And as I said earlier, it seems like they're identifying water ice in some of the Trojans. So let me go to the second part of the talk, which is these main belt comets, which are objects with coma and tails in main belt asteroidal orbits with an unlikely cometary origin, and here are several examples of these main belt comets. And specifically, there are, and back to the discovery of water vapor around asteroid Ceres, which was reported in a paper by Coopers et al., and we did a news and views on it, and this is the figure from that. So should one Ceres be called a main belt comet? Depends on which definition you will stick to. So it's an asteroid, dwarf planet, and a main belt comet. And so these two small objects in the Themis family is what motivated us to study Themis, trying to understand why, in this family, there would be these main belt comets. So these are 133P and 176P. And there's also another main belt comet near the Themis family, which is 2005 U1. So here's the two members of the Themis family that are main belt comets. And so these orbits are very unlikely to come from either the Oort cloud or the trans-Neptunian region. So we actually went and obtained visible spectra of these two objects, and we conclude that they are members of the family and not, they do not look like the nuclei of Jupiter family comets. So here's the noisy but acceptable in terms of at least the slope of the spectrum of 176P. 133P is brighter, we got a better spectrum of it. And then when we compare the spectra of these two objects, we need a stronger projector for this, but Els Pizarro's here compared with 62, which is Erato, one of the Themis family members, and two others. It turns out that, just take my word for it. Els Pizarro looks like these guys, and it does not look like the nuclei of Jupiter family comets. So if that's the case, then why are some Themis family members active and not others? For example, since we discovered water ice on the surface of 24 Themis, why is it not active? And it could be that a 200-kilometer diameter asteroid has enough gravity to prevent dust from escaping, and therefore we don't see it. It's been suggested that recent collisions may expose ice in these objects, and that explains why the activity is 133P. It could be that there's heterogeneous compositions among the Themis family fragments, and we have some spectroscopic evidence for that. And for that, the Gaia mission that the European Space Agency launched and is starting to operate will help on that, giving us spectra of many, many asteroids, actually 350,000 of them. So let me then jump to the third part, which is the two particularly interesting near-Earth asteroids that are activated. So these are NEAs that are active in some way, and these are 4015 Wilson-Harrington, also known as Comet 107P, and 3200 Phaethon, which is the parent body of the Gemini meteors. So here are these two objects, which we actually discussed in a paper back in '98, Tim Sundel and I, and in that paper we associated the fireball believed to have dropped meteorites with recoverable mass from the Halliday et al. Survey with 4015 Wilson-Harrington. And interestingly enough, of all the fireballs in the Halliday et al. Survey, the only one that was classified as chondritic was this one, 498. And so it likely dropped some meteorites in an agricultural area of Saskatchewan. They were actually looked for, but they haven't been found yet, not surprisingly. This is very difficult work. But then recently we've been doing some dynamical and spectroscopic work linking 4015 Wilson-Harrington both with the Polana family and with the Themis family, and it's roughly equally likely to come from either Polana or Themis, both dynamically and spectroscopically. We're working on that paper. That paper should come out soon. And in the case of 3200 Phaethon, as I mentioned, it's the parent of the Geminids. It's been observed to be active now. Papers by Jewett and Ling and Jewett et al. It was linked both spectroscopically and dynamically to 2 Pallas in a paper that we wrote, we published in 2010. And it turns out that the Geminids, this is relatively recent information, can produce meteorites. There's a very nice paper by Madiedo et al. 2014, and I was talking to Peter Brown about this. So if the Geminids produce meteorites, then we may be able to get samples from to Pallas through Phaethon and the Geminids. So these are some of the details of a 2010 paper on Phaethon, and it's linked to Pallas. And so what about the relevance to space missions? So I chose two examples, and it turns out that 24 Themis, 3200 Phaethon, and 4015 Wilson Harrington all have the same spectral classification. They're B-type asteroids, which is the same spectral classification as Bennu, which is the target of NASA's OSIRIS-REx sample return mission that we heard about earlier from Scott Sanford. And it's roughly the same for JU3. JU3 is a C-type asteroid, not a B-type asteroid, but still it's a primitive low albedo asteroid, which is the target of JAXA's Hayabusa 2 sample return mission. So I've given two examples of papers we published on this topic. So here are the conclusions again, and thank you. Yeah, that's a part of the talk that I actually left out in favor of the new work on NEAs. It looks the evidence is very strong in favor of comets and asteroids bringing the organics to the Earth, because if what we've been hearing about these magma oceans, both for the Moon and the Earth, is indeed the case, then any organics with which the Earth formed would have been burnt during that phase. So when the surface of the Earth cools and solidifies, that crust is completely it's sterilized. And so it is the delivery of, we know of the impacts with asteroids and comets, which are both rich in organics. So it's very, very likely that the prebiotic inventory of organics on Earth came from asteroids and from comets, which is the main scientific justification for the OSIRIS-REx mission.